Renaissance people, if you are enjoying the Italian Renaissance podcast, I have good news. We're now active on Patreon. You can show your love for the show by becoming a patron and get access to additional resources, information, and artworks. Better yet, those who join the Renaissance Master or Renaissance Patron tier will get access to at least one additional podcast episode each month. My goal is to ensure that the main podcast remains a free, accessible source for everyone. Become a patron today through the link in the show notes to support the continued production of new episodes and help build and maintain this community. The Italian Renaissance shop is now also active on Etsy, linked in the show notes. Sport our logo or choose from a growing selection of Italian art-inspired designs. Discounts are offered to select Patreon tiers as well. Your support has my immortal gratitude. Now, enjoy the show. Welcome to the Italian Renaissance podcast, where we discuss essential topics about the art and culture of 15th and 16th century Italy. I'm your host, Lawrence Gianangeli. Andiamo avanti. Hello, everybody, and welcome back. Let me first apologize for the delay in getting this episode out. I unfortunately had a pretty bad chest cold and wasn't able to get the interview underway like I wanted to. I've noticed steady growth in our social media accounts, and I thank you guys for that. If you have yet to follow us, we have a Facebook and an Instagram, both linked to the show. Check us out, follow us there, especially to get accurate images for when we discuss artworks. I also provide supplementary information, additional works to help further our understanding of the topics that we cover each episode. Lastly, hosting a podcast is a very labor-intensive process, and I want to continue to be able to provide the best historical information and research for all of my listeners. So if you want to support the show, that link will be available in the show notes. In any case, your ratings have been so helpful in keeping the show's momentum. So please leave some feedback wherever you listen. It really means so much, guys. So without further ado, let's talk Galileo Galilei. Before we start the interview with Ian Billig, I want to do a brief biography of Galileo, especially since we're going to talk in detail about him. Galileo was born in Pisa in 1564. That's home of the famous Leaning Tower. Pisa, like many other places we've discussed, was part of the Duchy of Florence. Keep in mind that's not the Republic of Florence. We're past the golden age of Renaissance art, more or less, and into a period where the expelled Medici family, we talked about Cosimo, we talked about Lorenzo the Magnificent, they've returned to Florence, meaning their descendants have returned to Florence, and they've effectively taken over the Republic, replacing it with a Medici monarchy. We have to be careful with periodization here. When the duchy was established in 1530, art was still what we would classify today as Renaissance, or even something called Mannerist. That's another topic altogether. But by the time of Galileo in the end of the 1500s and into the 1600s, science had yet to experience its own Renaissance, and thus we can stretch our terms and conditions as to what Renaissance means. Galileo is one of the most important figures of the period next to Copernicus, particularly in advancing human understanding of the natural world, closely in terms related to modern science. He was ingrained in the early university system in Italy at the time, if we can call it a university system, and can be referred to as what we would also call in modern times a public intellectual. Although, as we'll see, he wasn't always so public with his ideas. He was particularly concerned with astronomy, mathematics, natural philosophy, and the study of motion. This is why I need someone who understands physics on the show to help me sort through Galileo and his work. So, with a lot of information on Galileo under our belt, I'd like to introduce you guys to our guest today, Mr. Ian Billig. Ian, why don't you tell us a little bit about yourself, your education, your interest in classical Renaissance studies and science?
Yeah. Well, first off, thank you for having me on the podcast here. Pleasure to be on. I graduated from Ohio University in 2019 with a bachelor's in physics. I've lifelong love and fascination with history as well. So this is a nice intersection of my interests. Since graduating, I have been published. My name is on a paper, Bayesian model averaging for extrapolation of effective field theory expansions, some fun nuclear theory stuff. It's really just souped up statistics, but anyways, here to
We'll link your article in the show notes. So
I'll plug myself here a little bit.
Yeah, we'll give them a chance to give it a read. Sorry, keep going.
Yep, I am a veteran of Catholic school as well. 12 years, K through 12th grade through my senior year of high school. Obviously, during that time, exposed to a lot of kind of esoteric theology. 4 years of Latin as well. Not that I remember as much of that as I probably once did, but gave me an interesting perspective on how the Catholic Church has shaped history, both in antiquity and more through the Renaissance, and how, in turn, in a strange way, it's shaped science, or in some cases, as we'll see, inhibited it.
Right. The Catholic Church was a bit of a problem for Galileo. He was partially intimidated by them, but also was restricted in his movements by an overarching Catholic structure which dominated his society. All right, guys. So what we're talking about here are major differences in key terminology, namely natural science, write that down in your notes, philosophy, theology, and we're going to look at this in light of Ian's expertise in contemporary science. So if you want to, Ian, inform us on what natural science is, if and how it's different from philosophy, and how this all relates to theology.
Sure. So I think going back to antiquity, and in particular the work of Aristotle, I guess you could draw a line to its origin in sort of his teachings, or at least that's how it's been brought out to us. Natural science, philosophy, and theology were all intertwined. They were facets of the same sort of, this art of wondering. So natural science, natural philosophy, by definition, is the study of physics, but not physics in what we think of in the modern sense. Physics to the ancients was just broadly any sort of observation or pondering on natural phenomena. So that would include zoology, that would include the movement of celestial bodies, the stars, planets, etc. Just essentially not empirical. This is before the development of the scientific method, and that's going to be the key difference between natural philosophy and modern science. It's just looking at these things that we observe, that we sense, and philosophizing about them.
So this ties into exactly what we're always saying about Renaissance and what Renaissance means. It's re-referencing classical antiquity, and in this case, ideas about natural philosophy, not so much what we would have been talking about with Da Vinci, trying to emulate the natural world, but more so how to understand it. So Ian, in this light, Galileo is obviously referencing the natural philosophers from antiquity in developing a new type of science, a Renaissance science that we might call it. Who are the people, or what are the works, or how is he referencing the ancients in his own work?
Yeah, so I think a lot of Galileo's work, frankly, is in direct contrast to scholars of antiquity. It's not a straight line. He's not necessarily directly referencing Aristotle. I guess I conceive of it as him going against Aristotle through Aquinas. So Thomas Aquinas was a late medieval figure he's a father of the church, meaning that he and his work was foundational to late medieval theological thought. He was really amongst the first, probably the first theological scholar to try and reconcile Aristotelian thought and philosophy with the teachings of the church. He synthesized these two in essence. The idea was that Aristotle and his view of natural philosophy, at the very least, was correct and compatible with Holy Scripture and with the theological thought of the time, even if the gods he did or did not worship were not correct in the eyes of the Catholic Church. So Galileo contradicts Aristotle through Aquinas on specifically and very famously the concept of geocentrism, meaning that the earth is God's creation, is perfect, and is therefore at the center of the universe. All celestial bodies revolve around the earth.
So what we're essentially talking about here is the debate between geocentrism and heliocentrism. Can you explain that debate to us and tell us where and how Galileo lands where he lands?
Of course. So the prevailing thought in Europe, and I'd imagine a great deal of the world at the time, was that the Earth was the center of everything, as I mentioned, and that all heavenly bodies, everything that you see in the sky, orbits around it in these concentric spheres, basically. The issue with that is to mathematically chart the movement and predict the movement of these celestial bodies under this paradigm it's incredibly complex. So Galileo was directly working off the work of Copernicus, so the first European since the 3rd century BC to propose a heliocentric view of the universe. It helps clean up the math. One of the key differences between Copernicus's view of heliocentrism and Galileo's view of heliocentrism is Copernicus believed in the idea that these heavenly bodies have what are called epicycles. So it's essentially that, yes, everything moves around the sun, but they're still in these perfect concentric spheres. The problem with modeling the solar system like that is there's movement in the celestial bodies that can't be accounted for if you work on the assumption that they do exist on these concentric spheres. So to make up for these discrepancies, Copernicus supposed that they moved in what are called epicycles, basically little spirals along these concentric spheres. It's a little hard to describe just speaking about it. Wish that was could diagram it, but Galileo rejects even this. He says, yes, the celestial bodies still orbit around the sun, but they don't exist in perfect circles or spheres around the sun. They move along ovals, basically. In science, we call them ellipses or orbits with eccentricity.
Okay, so I know that today when we study astronomy, we talk about orbits in ellipses. So you're saying that Galileo actually discovered ellipses?
He worked under the theoretical framework that these orbits were eccentric, and that they were ellipses, yes. He didn't discover them so much. It's just, if you work under that mathematical framework, it makes your predictions and your theoretical procession of the celestial bodies a lot simpler to calculate.
So I think this is a really good segue into a resource I have here, one I've pulled from in the past for you guys, and it includes letters from Galileo talking about his relationship to Copernicus. I'm going to quote it here. Galileo says in his letter, "I accepted the view of Copernicus many years ago, and from this standpoint I have discovered from their origins many natural phenomena, which doubtless cannot be explained on the basis of a more commonly accepted hypothesis. I have written many direct and indirect arguments for the Copernican view, but until now I have not dared to publish them, alarmed by the fate of Copernicus himself, our master. He has won for himself undying fame in the eyes of a few, but he has been mocked and hooted at by an infinite multitude, for so large is the number of fools. Isn't that great? Yeah, that's great.
Good quote.
So, talking about his reference to Copernicus and how he improved on it, he mentions in that letter. Ian, can you tell us what is Galileo's contribution to modern science, but also how did he innovate on his period's concept of natural science or natural philosophy?
Yeah, he made many tremendous contributions to it's truly becoming science at this point. We're getting away from natural philosophy. He is the father of observational astronomy. He gets that title sometimes. He's not the inventor of the telescope, but he is certainly a pioneer of it. He had a refracting telescope that was capable of like 3 times magnification of celestial objects. So he is the first to observe the moon through this telescope and realize the dark spots on it are valleys, and he recognizes that there's these crests and craters, that the moon is not a smooth spherical object that has a lot of features that are reminiscent of things he saw on Earth. He was the first to see the famous Galilean moons of Jupiter, again through this famous telescope of his. The first observation of bodies orbiting a planet besides obviously our Earth's moon. So the 4 moons he saw were later called Io, Ganymede, Europa, and
I always forget the 4th one too.
The nerd stuff, yeah. And Callisto, that's right.
Callisto.
There's a nerd cred. I think what gets overlooked about Galileo and sort of the collective memory of him is his contributions to the field of kinematics, which is very fundamental to the conception of physics. There's the apocryphal story of him dropping the ball off of the Tower of Pisa. Probably didn't happen, but it is true he made contributions to how we conceive of how bodies move in space, just broadly speaking. Amongst the first to realize there's this difference between the concept of velocity and acceleration. Truly, he looked into this by observing how balls roll down ramps. Not getting into much of the details of his actual experiment. He was instrumental in framing how bodies move in space through the lens of Euclidean geometry. Of course, the geometry originally developed by Euclid, another classical source, treating space as three-dimensional. You can move through X, Y, Z, up, down, left, right, forward, backward, and then having an independent coordinate called time. This basic view of how things move was really the paradigm of how physics worked for 300 some odd years after the fact. It's not until the discovery of relativity that we realize time is not independent of space, but I'm getting a little ahead of myself here.
Just so you guys know, if you do happen to go visit Florence, there is a Galileo museum that has a lot of his original telescopes in it, in addition to, weirdly enough, his fingers. I don't know why, but if you really want to see his really long, gross phalanges, they're in like this creepy Beauty and the Beast jar inside of the museum in Florence. Additionally, there's a castle on the hills of Florence called the Torre di Gallo, the Rooster's Tower, and you can see it from anywhere in Florence. It just kind of blends in with the natural landscape. but it's up on the hill because remember, Florence is in a valley, and people don't know, but that is the very tower in which Galileo would have climbed to get the highest point he could in doing his astronomy observations. Now, there was a time where I walked up there, way up on the mountain, which doesn't have a path. It's just like a road with no sidewalks, and it was closed. So make sure you find out if it's open or closed before you go, if you want to climb the same tower that Galileo climbed and look at the bright sunny day, because they're not open at night and you can't look at the stars. So one of the most important things about the Italian Renaissance that makes it such a bedrock for Western culture is that it spread. It wasn't confined to Italy, right? So Italian culture, Italian art was spread throughout Europe as a result of the French conquest of Italy. And as the saying goes, it wasn't France that conquered Italy, but Italy that conquered France, because the French monarchy adopted the cultural norms of Italy after discovering what was happening there. So in order to get to our modern period, now we're talking Galileo, we're talking science, this spread as well. Beyond Italy, beyond the confines of the Renaissance, into what we know to be science today. Can we look at some contemporaries of Galileo who was influenced by him and how that transitions into modern science?
Yeah, so of course, Galileo laid the bedrock, the foundation of modern observational astronomy, and is in a lot of senses one of the first people to engage with physics in some senses we would understand it and what is true. The year Galileo died in 1642, coincidentally the birth year of an Englishman named Isaac Newton. You may have heard of him. Obviously, Isaac Newton is the father of physics in a modern sense, building upon the work of Galileo, in particular Galileo's contribution to kinematics. He was the first to recognize this phenomena of acceleration in contrast to velocity. Newton made many contributions that are frankly, well beyond the scope of anything we could or should discuss here. But he built upon the kinematics of Galileo, and in doing so, invented calculus. These concepts of velocity and acceleration, as mentioned, that Galileo looked at, are intrinsically related to rates of change, and to properly describe rates of change in mathematics, the language of calculus is necessary. I think Newton might have been one of the last scientists in Europe to still engage under this paradigm, as mentioned previously, where natural philosophy, theology, and what we conceive of as philosophy of being facets of the same thing. He was incredibly precise in his observations and in his mathematical rigor to describe phenomena, but anything that he couldn't describe, he ascribed to God doing it, essentially. He was deeply interested in theology as well as physics, and famously alchemy as well. So it's not to say that he was removed from any sort of what we call magical thinking, but he took everything to its logical extremes.
I love that you're mentioning alchemy here, because it has, of course, ancient roots, but also was a fascination of the Renaissance naturalist. Can you just explain to the audience, please, what alchemy is and what alchemists are seeking to do?
Yeah, so alchemy is basically concerned with, I think the term is transmutation of substances. People associate it mostly with trying to turn other metals into gold, etc. And it did lean on arcane magical sort of knowledge, magical recipe books, etc. But in investigating these materials in this way, think people began to think, the premise was incorrect, but sort of the methods that they went about doing it led to a rigor from which modern chemistry sprang.
I've always found alchemy to be very interesting, but of course, not in actual science. It turns out that it doesn't work. That you cannot turn other metals into gold, much to the despair of these old natural philosophers. However, now Ian has not been prepped for any of these questions, but I've written up 5. I guess they're not questions. I've written up 5 points. We're going to double back to Galileo here. And these are scientific discoveries or hypotheses or things that Galileo believed or found to be true. And my question for Ian is going to be, is this still true? Does Galileo's concept of either astronomy or physics or science hold up today? I have 5 questions. And we're going to start with the first one, and we're going to get a little more complicated. So first, what I want you to do, Ian, is answer yes, true, or not, and take that time as you like to, if you want to develop the point, okay?
Sure.
So we're going to start with an easy one. Again, these are claims by Galileo. Saturn has rings.
True.
Anything you want to add to that?
I can't imagine, I don't know this for a fact, I'll admit this is speculation on my point. I can't imagine Galileo had any concept of what those rings were. Maybe he had a concept of why they were moving as they were. He'd be familiar with gravitation, or at least some aspects of gravitation. But this is very much a fact, yes. There's icy materials that orbit around Saturn.
Awesome. Number 2, we've talked about some of these guys. Jupiter has 4 moons.
False. Jupiter has, I don't know how many moons we're at this point.
16? Something like that?
I feel like they come out with a new one every few years or so. Some little pebble, some little rock they find orbiting it. Jupiter also has a ring, I'd point out too. It's barely visible, and I think that was a fairly recent discovery in the scheme of science at least, but a thin little ring does exist, so...
Very cool. So Galileo discovered the first 4 moons of Jupiter. We continue to discover more every time a new iPhone comes out.
Something like that.
All right, you ready for the third one?
Sure.
Without air resistance, objects will fall at the same acceleration independent of their mass.
It's going to depend on what body you're on. If in the sense if we were on Earth and we took away all the air, then yes, it's just the acceleration is independent of the mass. Famously during one of the Apollo missions, I can't remember who it was. One of the people on the moon brought a hammer and a feather or something like that, and showed that Galileo was correct. These things fall the same rate with the absence of air.
I didn't know that. That's pretty interesting.
Yeah.
All right. Number 4, you ready?
Okay.
Objects that are more dense fall at a faster rate than objects with less density.
Objects that are more... say that again?
Objects that are more dense fall at a faster rate than objects with less density. A denser object falls faster than a less dense object.
This is something that Galileo said?
Yeah.
In the absence of air resistance, that's not so much.
Not so much?
No.
Not true?
Nope.
Okay, so with or without air resistance, tell us what is true in terms of density in falling objects.
So I think Galileo had the insight, or he observed that it is because of air resistance on Earth that we see, for example, a feather fall much more slowly than like a bowling ball or something like that. And absent, with the absence of air resistance, a frictional force proportional to velocity, things experience the same gravitational attraction, acceleration. Excuse me.
I see. So I'm going to take this question 3 and 4. So without air resistance, true, objects will fall at the same acceleration independent of their mass. However, with air resistance, objects that are more dense fall at a faster rate than objects that are less dense.
So, I think a lot of that's to do with the geometry of the object that you're talking about. Air resistance is, there's a joke amongst physicists that we're all lazy because we always ignore air resistance, which is obviously something you can't realistically do. It's a messy thing to try and model. I think with the example of a ball and a feather, the geometry of the feather and how the air flows through the feather and creates friction is going to be the deciding factor of that.
Very cool. Very cool. All this stuff is beyond me, guys. I look at pretty pictures. Okay, so my last question in our Still True game here. And this is one that I know you're passionate about.
Alrighty.
So that's why I left it for last, and I'll let you say anything that you want about it.
Uh-oh.
So, this is according to Galileo. In order to quantify nature, mathematics is better than words.
Are you asking if I think that's the case?
Is that true?
Oh, absolutely, 100%. I'm very passionate about mathematics. I suppose you kind of have to be to study physics in a sort of modern sense. If we want to link it back to classical thought, we can go full circle here. Many mathematicians, and I would consider myself of this belief too, many mathematicians feel that are what are called Platonists. So they think that if you're familiar with the famous allegory of the cave from Plato, where perceived reality is just kind of a shadow or an emanation of some deeper truth. I'm probably muddling this because I'm no philosopher, but
that was right.
Okay,
that was right.
This is all to say that I think mathematics is a reflection of a deeper truth that math does exist, is real, and that anything we see, any physical phenomena, so by extension the field of physics, is just an emanation or a shadow of this deeper truth, this deeper reality of math. So I'm very much on Galileo's side on this. I think he was thinking along the right lines.
As you guys can see, especially if you've listened to past episodes, it is really the obsession of these Renaissance minds to discuss what emulates nature the best. For Leonardo da Vinci, it's painting. For Michelangelo, it's sculpture. Even though his idea of emulating nature is a philosophical emulation of perfection, divinity, right? And now for Galileo, it's mathematics. So lastly, Ian, I want to give you the floor to talk about anything that's lingering, anything else that you want to get out there, and what you want listeners to take away from this before I get to my final question for you. So go ahead, the floor is yours.
Sure. I guess just in preparing for this podcast, I was doing some more reading about Galileo and his contributions and just sort of the history of physics in general. And I really think you can look at Galileo as maybe the turning point, his work as the turning point in physics, where it really starts to look like what we would recognize as modern physics. His as the quote you previously mentioned, where mathematics is sort of king, it's the best descriptor of the universe. I think this tenet is what brought physics to where it is now. Ultimately, he laid the foundation, as previously mentioned. Newton vastly improved upon it. He took the rudimentary kinematics of Galileo and developed into a field called mechanics, classical mechanics specifically. Again, just a field concerned with the motion of bodies in space. Newton, amongst others, realized that the same principles of how things move and behave on Earth are applicable to the heavenly bodies that we see. These things aren't separate. And it was some of these ideas that laid the foundation for physics as we understand it today. And these guys, it was improved upon after Newton, through the 1800s, basically. It was so precise a description of the universe at the time. There was a sense almost by the turn of the, midway through the 1800s, that physics was almost done, that anything we could see could be rationally explained through the language of mathematics. We had a complete, beautiful view of the universe, and it was this magnificent triumph of humanity that we achieved this. I mean, this is the hubris of Enlightenment thinking. Again, we're getting a little outside the scope of the podcast, I think, because we start to find holes in some of these theories, which ultimately lead to the development of modern physics, which is obviously very much still ongoing, nowhere near complete. Things like relativity, quantum mechanics. We get into field theory later on, yada, yada, yada. I'm rambling at this point, but the deep admiration still, and I think the principle that the universe is fundamentally and inherently mathematical is the case.
I think that's a beautiful summary of everything that we really wanted to take care of in this episode. If you guys remember the interview with G. Cooper, I kind of ended it with a quirky, irrelevant question, and I have one for Ian today that regards Galileo. Are you ready?
Gotcha, yes.
This is going to be a bit of maybe a philosophical question. Maybe you actually know the answer. I don't know. What is Freddie Mercury talking about? Why is Freddie Mercury?
To be honest, that's bothered me since I was a kid. I remember very distinctly driving around with my parents, and they'd have the classical rock station on. I'm like, Galileo, what the hell are they talking about Galileo for?
Did you ever figure it out?
I don't. I have no clue, to be honest with you.
If you had to answer that question, like an exam essay, if it said, "What is Freddie Mercury talking about?" What do you think?
I have to remind myself of how the lyrics go here, because it's what the song's like. Mom, I'm sorry, I killed a man. They're gonna put me to death. That's basically the gist of it. Yeah. Maybe just spitballing here. Maybe the persecution of Galileo. He's relating himself to.
That's a good point.
What he felt.
Yeah, well,
I have no clue, to be honest.
Because Galileo, of course, would die in under house arrest. For heresy. Yeah.
Under the persecution of the Catholic Inquisitors. Yep.
Right. Okay. That's a good answer, actually.
It's a fun one.
Yeah, and a good way to round off the podcast. Thank you all for listening. Let's say goodbye to Ian.
Pleasure being on the podcast. Thank you for inviting me.
And we'll catch you all in 2 weeks. Arrivederci.